Welcome to CrystalMaker 11. In this tutorial we'll explore the new Angles Explorer introduced in CrystalMaker 11.5. Now here we're looking at a model for amorphous silica, and we can see quite a disordered arrangement of atomic positions. We'd like to map the distributions of bond angles. To do this we'll use the new Angle Distributions command. Measure angle distributions, and this brings up a new window, the Angle Explorer, showing a default angle search on the left hand side, searching from oxygen to oxygen and silicon, and the results are presented on the right in graphical and tabular form. Now I'm interested in silicon, and specifically bonds from oxygen to silicon to oxygen. This is the essential tetrahedral angle that helps define the unique structures of such a wide range of silicates. We'll specify this critical bond angle using the sidebar on the left. Let's search from silicon to oxygen. And I want a smaller maximum distance of around 2 angstroms, so I'll go down to the max distance field here and type 2 and then hit enter to show that. We now have a histogram showing a distribution of angles around silicon to oxygen in our structure. That is oxygen, silicon, oxygen angles. Now to create this histogram, CrystalMaker has to search over all the sites containing the target element in our structure. Now the target element is now silicon, which we specified in the search list. And if I expand that element row, we see all of the sites containing silicon in our structure. And there's an awful lot of those because this is a disordered structure. For each site found, CrystalMaker measures the included angles and then presents their distribution in the form of the histogram. For example, the average number of silicon sites with an included angle of a particular value. Included angle is the x-axis, and then the numbers found are the y-axis. Now that we've defined our search, we can hide the sidebar to give ourselves more room. Below the histogram is a table of results. Each row shows a trio of elements: oxygen, silicon, oxygen, their included angle, and then the pair of distances, oxygen to silicon, silicon to oxygen. And we can sort the results by clicking on a column header. Double-clicking on a row shows its position in the histogram. Now, when a row is selected, we have a very cool feature, which is we can visualize the actual atoms in your structure. To make that visible, let me resize our Distance Explorer. And here, underneath, is the crystal structure with 3 atoms corresponding to that histogram row selected. Okay, let's select some more, and you can see the selection appearing in the document window. Our table includes a search field which lets us find a specific central site in our structure. For example, silicon 52. There it is. You can also arrange the table vertically if you need more scrolling space, and we have a little rotate layout button here that will do that. You can use the separator to expand the list horizontally. Let's go back to horizontal. Clicking on the histogram reveals this cursor, which you can click and drag to reveal some measurements. And we could use standard multi-touch gestures to zoom or scroll. I'm sliding 2 fingers across my trackpad to emulate a track wheel. You can also click and drag with the mouse to scroll horizontally. Now we have a tool strip up here, and that includes a pair of zoom buttons, an auto scale Y and auto scale XY. And we have other buttons to allow us to set the fonts, for example. Let's go for some bigger fonts, and let's choose something a little bit more interesting. We can set the style of our graph with the Style menu. And let's go to a column. And let's go to set the opacity of the graph. Let's hide the title. Let's change the line width. Let's turn off the shadow. Let's turn off the grid. And we can also set the width of these histogram bars. We call that the bin size. We have some presets that you can click, and you can use the slider for that as well. Many people ask about output, and we have a menu for that over here, the output button, which allows us to copy the graph to the clipboard. Incidentally, you can just click and drag the graph, click and drag into another graphics program, but you can use the output menu to copy to the clipboard as well, or you can export the graphics to a PDF, print them, or export a table of XY points for the plot. And finally, you can export that table of data to a text file. So let's do that. And here is our text file, and you can see that we have everything that was visible on the screen. We have the angle, we have the individual atoms involved with their site labels, their included angles, and then the 2 bond distances, oxygen to silicon and then silicon to the other oxygen atom. So that was our new Angles Explorer. It's a way of visualizing disordered structures in terms of numbers and graphs, and it allows you to precisely analyze particular atom site combinations. We hope you find it useful.